going to, if I get the right slide up here, I am going to go over the focus question. Or if I say focus, open, or same thing. Everybody else now has a periodic table. Did you need one, Tatiana? You just came back. You have it. You do need one? Okay. What? I have to take a look at the one commission. Let's see.
What does intensive and extensive mean?
Intensive means every single atom of that substance has that property. And so things like,
Volume of the same.
no. A volume is not. That depends on how much matter is present.
So it's extensive.
The volume would be extensive. Well, with every piece of that type of substance have the same density. So that's an intensive property. So the internal property, they all have it.
What about the boiling point missing?
Boiling point? Do you think that would be determined by how much is present? What temperature does water boil? Yeah, does it matter how much water is there? No, so that would be what, intensive or extensive? Intensive. All right, so let me go over this opener first. Unfortunately, with the Smart Ink, I can try drawing on the board. I know it's not going to work. I'm just going to have to talk this one through because, you know, try. We know it's not going to work. Uh-huh. Well, the thing isn't even lit up. So, I mean, I can attempt, but I already know full well this is not going to work. See? It just doesn't. It just doesn't. I don't even know where the Smart Ink has been pinned. It got pinned onto the...
You had it on there, but then you like put the freeze thing on it and you were like...
I know, because the smart board is possessed by the devil. Well, it's writing on my Google Meet thing. It's not writing on that. So I'm going to have to just explain it like I normally do. It's really frustrating. I need to have tech come out and take a look at my board and figure out why it's doing this. Because this is just stupid. All right, so we have aluminum phosphate, and N is short for molar mass. So we're going to be using the periodic table like how we've been doing. What is the symbol for aluminum? Al, and do you remember its charge? Positive 3. A phosphate is phosphate or phosphate. Phosphate is one of those polyatomic ions. Yeah, it's PO4 with a -3. Now, I don't think I yanked this up into this module. If you remind me, or if I remind myself, I will yank this back up to the top of this module. But phosphate is one of those polyatomic ions. But the charge is already added to 0.
Yes.
Yeah, so I don't have to write any extra subscripts, but I have to keep this 4 because that's part of the phosphate ion. I can't get away with getting rid of it. So I'm going to calculate for aluminum phosphate, which is Al, capital P, capital O4. We're going to calculate its mass. Now, this is specifically a gram formula mass because this is an ionic compound, but it's still done the same way. So you have to find aluminum on your periodic table. Which, oh, if I have to look them up, I know you have to look them up. And underneath aluminum, with 2 numbers after the decimal, what is the mass of aluminum? Over here. No, the 2's not enough to round number 8 up though. 26.98. But how many aluminums do you have in aluminum phosphate?
1.
I got one of them. Each one is 26.98. 26.98. So anything times 1 is itself. Once again, I'm getting this number from inside the block for aluminum. It's the bottom number, and yes, we're rounding, even if they're both zeros, like oxygen. We're rounding the 2 places behind the decimal. How many phosphorus atoms do you have?
4.
No, you do not. You have 4 oxygens. You have 1 phosphorus. Each one is 30.97. It's okay. 97. Now you have 4 oxygens. I know oxygen off the top of my head. It is 15.999, which rounds up to 16.00. You guys do need calculators. I do not care if you use your cell phones as a calculator. It's going to be easier to do that way anyways, instead of using the Chromebook. I do have calculators up here. If you need one, we'll disinfect it. We're at 256. So how do you calculate the molar mass of aluminum phosphate?
I'm more familiar.
Put it all together. So 256 plus 30.97 plus 26.98. And I get 313.95. And that is in grams. That is equal to 1 mole of aluminum phosphate. Yes, the abbreviation for mole is MOL. You cannot abbreviate molecule this way, because a mole is not a molecule. A mole is huge, and a molecule is tiny. But this would be, if I was doing a conversion problem, which is what we are spending all day doing today, this was the number I would have to use. Now, if you have not noticed this trend yet, if you're starting in grams and you're trying to change it into moles, you should be dividing by that mass. But if you're starting in moles and you're trying to change it to grams, you should be multiplying by that mass. It is more important to put your units down in the proper place first, and then come back, and where the mole is for aluminum phosphate, we get a 1. And when the gram is for aluminum phosphate, we get 313.95. I do not care if you use the fence post or the railroad tracks or the goal post, whatever you want to call it, or if you do the parentheses with the factor method, because it's the same thing. So let me take a look at Jimmy's real quick here. You are going from moles to grams, you're multiplying. You are going from grams to moles, you're dividing. Grams to moles, you are dividing. Yes, your top part looks just fine. As long as you added your numbers up right, you look like you're doing okay on the Yes. What about number 4? Jared, turn that off. Jared. Turn it off. We're going to get ears. You're going to get deaf. Exactly. Okay, number 4. What about number 4? Okay, well, hold on. Your mass, Jimmy, for aluminum phosphate on here is not right. But I don't know how you got this number. You have 121.
Well, we start with more, right?
Oh, 4 times 16 is not 256. You guys let me do that wrong. I put a wrong button on the calculator. 4 times 16 is 64. So I had a problem, not you. There was something else I noticed that I had done wrong on one of them. I taught it in the 8th period. No, don't just double check my math too. I apologize online. 4 times 16 is not 200 and whatever the heck it was. It was 64. So 30.97.
Well, I just made it that.
Hold on, 26.98. You're probably right. 121.95. I can't math very well sometimes, so I have to use calculators. So no, this is correct. Okay, so with number 4, what are you starting with? Okay, so you've got 0.7800, which I know that the zeros are redundant, but that's because I want 4 numbers in my answer. That's going to go on the top left-hand block. What do you have to drop in order to not be in moles anymore? Moles. And what are you going to change it into? So that means that the mole would get what number? Because that's aluminum phosphate's mass. No. Let me draw it out on the board. I'm so sorry, remote, because if I even try to show you my board, the angle is so off that you can't see it. What are you starting in? You tell me what the starting part is for number 4. How many?
0.7.
And that's in moles. And we are aluminum phosphate. It should be over 1, because over 1 doesn't change anything. What did you say you have to do with this unit so it'll divide out? Drop it. Please do not be lazy and leave off unit, and the compound is part of the unit. What is it asking you to change it into? Grams. And this is your conversion factor, where the mole is going to get a number 1. That's going to go right here. And then this is your grams is going to get this number. I wish I had different colors, but like all of my space kids like keep messing with my stuff. You're going to notice until we are changing between substances, the mole is always going to get a 1. And then the thing that's not a 1 goes to the other unit. Right now, we're focusing on going between grams and moles because we use molar mass for the rest of the year. Now, we had already talked about Avogadro's number, which on Friday, you guys were supposed to tell me what you wanted to do for your molten. I haven't checked them again. That was your attendance thing. That is the actual submission, like the real thing that you're creating. That is going to take that as a test grade. Well, this, I mean, it's not really hard. It's just a matter of making sure you're getting to on the decimal. This does not go away. So before I move on to taking a look at the other paper that you guys have, is there a question, seriously, where I got any of this from?
Well,
Yes?
would it be like, names would be like 4 digits in there?
4 digits. So,
4 digits after the decimal?
no, total. Total. The zeros in the front do not count.
Do we have to round?
You should round, yeah, you have to. So, what did you get after that? 0.1?
5,
.121? So that 1 is not enough to round to 2 and it stays the same. Right, is there anybody that needs me to disinfect the calculator for them that's over here? Or do you guys all have access to one either through your phone or through your Chromebook? Because I'm gonna have to wipe these things down if you're gonna use one of mine. There has been so much gosh darn COVID going around. With this new paper, and I need to check online attendance in a second. And like I said, I'm so sorry about this like beam that goes through the middle of this. The top part is just calculating your molecular masses, your molar masses. And then it gives you how to work out some examples. We're not doing Avogadro's number right now. I tell you that a mole is 6.02 times 10 to the 23rd particles. We're going to come back and start using that tomorrow. We already talked about this number, but that's not going to be in any of your math on this page. It says that a mole is equal to a molar mass. You have to be able to calculate that using the periodic table. And then it says 1 mole is 22.4 liters of the gas at standard temperature and pressure. We're not dealing with that one yet. But those are our different conversion factors or blocks or building blocks to be able to work the math, to be able to work stoichiometry problems. And then I have some of them worked out for you down here on the bottom, just to give you a correct example to solve a problem. Do not leave off a unit. It's either going to be moles or something on here, or it's going to be grams of something on here. If you start getting lazy and you only put down numbers and you don't put down units, when we get to the hard stuff, the 3, 4, 5-step conversion factors, you will get lost. Are you trying to hand that to me? Is there anybody? Okay, so yesterday was either you ready to turn in or you have a question. No. Okay, so on today. Which I don't know if I have any more copies of yesterday's or not. I have to look. These should all be one-step problems. You absolutely have to show your work. If you do not show your work, I'm not going to give you credit because on this paper, I gave you all the answers. So if you take a look at number 3 on the front, down here on today, the one that you should be working on, it says how many moles are in 22 grams of argon? And then it tells you 0.55 moles. That is the correct answer. I do this, not all the time, but I do this from time to time to give you instant feedback. Are you doing it right or not? Or if you're confused on how to round, these are the correctly rounded answers by sig figs. So if we work out number 3 together, top part is just molar mass, everything else is a conversion. Once again, I don't care if you do this way or if you do it this way. This is how I do them. And every time I need another step, I just put another line. What are you starting with on the bottom 3, the bottom of the first page? What are you actually starting with? 22 grams of what?
Argon.
Argon. So 22 grams, argon is AR. It's over 1. If you rather would do this as a factor, I honestly don't care, but once again, if you do not show your work, you're not getting credit. Same thing. What are you trying to change it into?
Well,
Moles. So that should be up here. So how do I make this jump? What is it that's missing here that lets me go to moles? Grams. So this unit, I don't care what you start with, it's going to drop. How do I figure out my numbers for the holes? And I'm doing the exact same thing. I'm just showing you the 2 different ways that you can do this. However your brain likes to do the math, choose that way. I just do it this way. How do I figure out what this works? Then what we go on the top? So if you find argon, I get 39.95. But is that a gram number or is that a mole number?
no.
1 mole is so many grams. 1 mole has so many particles. 1 mole has a certain number of liters. What we're working on right now is just moles and grams. So right now, until we use coefficients for balanced equations, the mole is going to get a 1. Period. The mole is going to get a 1. The mass is off the periodic table, which in the case of argon is 39.95. I'm no longer in grams. Do I need to multiply or divide by 1? Does it change anything? No. So is this multiplication or division? It's division. I said, you have to have a calculator. I don't expect you to do this in your head. I don't do it in my head. 22. Calculator. God, shit. Divided by 39.95. And what my calculator says, no, I pushed the wrong button. Okay, this is what the calculator says. It says 0.55068836. How many numbers are in 22? 2. Mass does not affect sig figs. It's completely controlled by how many you're starting with. The 0 does not count. Is this 0 going to round the 5 up?
No.
So that is why the answer is correct at 0.55. Now I am in moles of argon. I went back and I had to reprint this multiple times. The last district that I taught chemistry at, they only needed 1 behind the decimal. This district is actually needed 2 behind the decimal. So it changed my answers just a tiny little bit. But I didn't want to give you guys answers that were off by a few tenths or hundredths. And then you'd be like, well, I'm not getting the right answer. These answers are rounded to sig figs. Now, since you have the rest of the period, if you have questions, is there who has a, where are you getting that from? Because you should be working on these. Now, you haven't been here for a while, so do you see where I got those numbers from? And once again, for anybody that does need a calculator, I mean, I would not be touching other people's stuff as much as possible right now. In no specific, okay, then what we're doing, and I can stop the recording, I need to check my attendance online real fast. Sodium would be, the mass would be 22.99. Attendance. Okay, so let me check them really fast. And this also goes for those of you that are online, because you couldn't see me writing this stuff on the board. If you want me to, I can bring up like a Google Doc. It's just going to look like a 3-year-old is writing on the screen because I have to use my mouse. Alexis is here. Reagan is here. Declan is here. But for those of you that are remote, if you don't like unmute yourself and say something, I'm probably not going to notice it. Lucas is here.
On this one, are like they already like rounded and stuff.
The answers?
On this one.
Some of them, they only have 2 behind the decimal. So they're okay. Like zinc is 65.38. Okay, but I mean, ones like mercury, which is 200.592, it should be 0.59 after the decimal. Let me check in here, and then I am free if you have questions. We will have another day like this on Friday. Right now, they are all one-step conversions. Each up and down bar represents a new step. Starting tomorrow, we are going to be doing, sometimes they're single step, but normally they're going to be at least 2. I shouldn't ask you to really go much beyond 3 steps at this point, not yet. But I'm not trying to scare you by doing more than a 1-step conversion and really doing more than calculating the molar mass. That person's not here. That person's not here. See, Jarrett Braden is not here. Caitlin, Slate, Sahara, Tiffany, Lucas is online. Declan's online. Tatiana, Alexis is online. Jimmy, Sebastian, Matthew, Bailey. I can stop. I can stop the recording.